Hi, in this video I will be talking about measuring capacity and the factors and equations that we need to measure the capacity. Before we start, we need to ask ourselves, why is it important to measure the capacity of our company? Well, it is important because you need to know what's your ability of fulfilling the customer's orders. So we need to know how many units we need for the month, and we need to know, are we able to fulfill these units, assuming that we need this month 100 units to sell it to the customer, to send it to the customer. We have to figure out if we have enough employees, if we have enough time, if we have enough machine to fulfill this demand. In order to measure the capacity, there are two ways to measure the capacity. One is the units of output, and the units of output, basically, it's how many units you can produce. And it could be tons, or could be gallons, or could be any kind of measurements that you could measure the unit with. A second measuring capacity factor is the standard time. The standard time is how long it will take you to make one unit in your company. And we use time studies a lot in companies. Whenever a company contacted me and say, we need to consult with you and we need you to improve our process here in this plant, what I do, the first step that I do time study. So time studies are really important. We need to consider it anytime. So, and that's why it is linked to the capacity. It is linked with the efficiency. It is linked with the utilization. So there are two types of capacity that we could measure the available capacity. One is the demonstrated capacity, or what we call the measured capacity, and this is basically based on historical data. We look back into the past month, the demand for past month, and we take the average, and this way we say, okay, well, over the past 3 months we made an average of 150 units. So this is your demonstrated or measured capacity. The other way for calculating capacity could be rated capacity, and rated capacity is based on the available time, utilization, and efficiency. So these are kind of the things that we will cover in this video. Just to summarize, we will be covering the available time that we have, utilization, efficiency, time needed to fulfill requirements, and the different type between demonstrated capacity and the calculated capacity. Alright, we're gonna start with the first concept here, and I'm gonna share with you my screen. So the first concept would be the available time. And the available time, it's basically the number of hours at a work center can be used, and this depends on the number of machines, number of workers, and the hours of operation. Let's go ahead and take an example right away. A work center has 3 machines and is operated for 8 hours a day, 5 days a week. What is the available time? So we have 3 machines. Each machine will work 8 hours a day, and we have 5 days a week. So that would be 3 times 8 times 5. The available time is 120 hours per week available in that work center. Second concept, the utilization. And the utilization can be calculated by finding out the hours actually worked divided by the available hours times 100%. Okay, moving on to the second example. A work center's available hours is 120, but actually produced goods for 100 hours. What is the utilization of the work center? So actually they worked 100 hours divided by the available time, 120 times 100%. So we have an 83% utilization for the work center. We could do better. We could have 100% utilization. This is the ideal situation, but in the real situation, it's rarely we could find the 100% utilization. No matter what you do, you still have a utilization less than 100. But the goal is to receive a number close to 100% to achieve a better utilization, and which means that you're saving a lot of money and you efficiently use your resources. Okay, the next concept is the demonstrated capacity, and we talked about demonstrated capacity as based on historical data. So you look into the months, like 4 or 5 months ago, and you find the average of what you've done before, and based on that you say, okay, my capacity, I'm able to produce this unit. Okay, let's go move on to an example problem. Over the previous 4 weeks, a work center produced 120, 130, 150, and 140 standard hours of work. What is the demonstrated capacity of the work? So you add all these together, 120 plus 130, 150 plus 140 divided by 4. That would give you 135 hours. That could be your capacity. So your capacity is 135 on average. All right, let's move on to a more challenging question. Over 4-week period, a work center produced 540 standard hours. So this is the actual one, what they've done. Available hours is 640. What actually worked is 48 hours. Okay, so we have 3 numbers: actually produced, actually hours worked, and available time. Utilization, based on the equation, hours actually worked divided by the available hours. Actually worked is 480 divided by the available hours, 640 times 100%. So we have a utilization of 75. Now we're talking about the efficiency. Efficiency would be the standard hours for work produced divided by hours actually worked. Okay, how many units we actually produced? We produced 54 divided by the actually hours worked, 480. 540 divided by 480 times 100%. We have an efficiency of 112%, this is great because they exceeded what the available time. They made more effort in order to achieve the orders. Another example on the efficiency. A work center produces 120 standard hours of work in 100. What is the efficiency? So 120 divided by 100 times 100%. That would be 120% efficiency. These are very efficient. Rated capacity is based on the available time, utilization, and efficiency, and we can calculate it by multiplying these 3 factors together. Let's take this example right here. A work center consists of 4 machines and is operated 8 hours per day for 5 days a week. Historical utilization has been 85%, efficiency 110%. What is the rated capacity? Okay, let's do the available time. First of all, we need the available time, we need the utilization, the efficiency. Utilization and efficiency is given in the question. Now the only thing that we need is to calculate the available time. Available time, we need to find out how many machines. We have 4. Each machine works for 8 hours and we work 5 days a week. 4 times 8 times 5, that would be 160 hours per week available for us to use. Rated capacity would be 160 times 85%, which is the utilization, times 1.1 or 110%, and that will give you a 149.6 standard hour. This is the capacity, the rated capacity and it is more accurate actually than the demonstrated capacity, because demonstrated capacity is based on the history and you don't know what the environment was on that day, but the rated capacity is based on efficiency, utilization, and available time. Okay, moving to the last question here, the last example, two more examples actually, and this is how we could find out time we need to fulfill the order, time needed for each order. Okay, and this is based on, there are so many factors, and I highly recommend you guys to read the PowerPoint. There in the PowerPoint more examples and more concepts related to the time needed, including the waiting time, the queue time, the scheduling. These are really important concepts that I don't want to focus on these in here in this video, but these are really important. So this is going to be a good start for you, but from here you could go continue on the PowerPoint slides and finish that and read it. And if you have any question, please send me an email. Okay. Time needed for each order. Here's an example. A work center is to process 150 of specific product. The setup time is 1.5. The run time is 0.2 hours per piece. What is the standard time needed to run the order? Okay, in order to fix the machine and make it ready for us for production, we need 150, this is what we call the setup time. You adjust the blade, you plug the electricity, you clean it, you make sure that it's in a good shape. This will take you 150. Some of the machines will need programming, like the CNC. You probably want to do a couple of trials before you start the actual production. So anyway, this is what we call the setup time. So this is where you make sure the machine is ready to produce units. So in this example, we need 1.5 hours to a setup time, and we need, for each one unit, we need 0.2 hours per piece. In order to finish this piece, we need 0.2 hours. What would be the total time for 150 units? So the setup time would be just one for all of them, so we don't need to calculate for everyone. So it's just, this happens at the beginning of production. You fix the machine, you make sure the machine is ready to produce, and that's it. It's one time during your production time. So 1.5 is only 1.5. You don't have to multiply it by 150. But for the run time, which is the processing time, this is how long it will take you to process one unit. It would be 0.2. So this is where you need to find out how many times you need for the 150. 150 times 0.2 plus 1.5, that will give you 31.5 standard hours to finish the full order. Okay, let's get a more challenging example here. We need to find out the actual time based on the efficiency and utilization. Okay, in the previous problem, how much actual time we'll need to run the order if the work center has efficiency 120 and utilization 180. Okay, looking into the capacity, and this is what we call the rated capacity, right? In this example right here, if you remember, the rated capacity is equal to available time times utilization times efficiency. Okay, so we'll put this example here, the equation in time, efficiency times utilization, and we're looking into the actual time. Capacity required, we just calculated the required capacity, what we can do. This is what we are able to finish. 150, we can finish in 31. So 31.5 divided by the efficiency, which is 1.2 times 0.8. The actual time would be 32.8 hours. 32.8 hours. This is the actual time, what actually we need in order to fulfill this order. One more last example. Actually, this is the last example, and this is similar to the homework that you have. We need to find out what's the total time for this order, and this is similar to what we have done. You need to find out the setup time, the run time, and how many units you need to produce. Starting with the first one, what I'm gonna do, actually, I'm gonna go here and to Excel, and I'm gonna take these numbers. We need 100 units here, 150, 200, 300. This is quantities. And setup time. And the run time. And here we need to find the total time. So we have the order released 222, 33, 3, 44, 4, and 55, 5. So the setup time is 0 here. We don't have any setup time. 1.5. One here. 3 hours. 2.5. Runtime 0.2. 0.2. 0.25. 0.15. Okay. Total time would be setup time plus open parenthesis runtime times how many units we need, 100 units. So for the first order number 22.2 or 222, we need a total time of 20 hours. Okay, we'll do the same thing, and the easy way is just to copy and paste, or just drag the cell from the right lower corner, and that will calculate. It's exactly the same thing. Setup time, which is 1.5, plus D6, which is the run time, and how many units, 150. That will give you 31.5. Now right here we do same thing. I'm gonna just copy and paste, delete this. Okay, again, setup time plus the total runtime for all the pieces that we have. That will give you 53 for order 44.4, and for the order 555, same thing, setup time plus the runtime times the quantity, and that would be adding all these together. If you add these, auto sum. So the total time in order to finish this order, assuming these are 4 separate orders, the total time we need 152 hours in order to fulfill this order. Okay, that's the end of the video. Please review the video, review the PowerPoints, read the book if you need. If you have any questions, please send me an email. Thank you.